vectors. Remember in our previous class we talked about scalar quantity and vector quantity. We say vector quantity are those quantities that has both magnitude and direction. Vector quantities are those quantities that has both magnitude and direction. Scalar quantities are those quantities that has only magnitude. Has magnitude only. Things like area, volume, distance, they are scalar quantity. Distance, speed, they are all area, volume, they are all scalar quantity. Temperature, they are all scalar quantity. Things like force, acceleration, displacement, moment, all these are vector quantities. Okay, so things that have both magnitude and direction are vector quantities. Now we say beside that, we say vectors can be added by two ways. There are two ways of adding vectors together. Number one is the normal addition. Normal addition of vectors. Addition method. So you can call it addition method. Just adding vectors together. Okay. The second one is called the parallelogram rule. The second formula for adding vectors together is called the parallelogram rule. Or you call it the algebraic sum. Parallelogram. So these are normal addition and parallelogram rule. These are two ways of adding vectors together. These are the two ways of adding vectors together. Now, if vectors are in straight lines, we just do the normal addition. If they are in opposite direction, we subtract them. If they are in the same direction, we add them together. So like this one, say, example, it has given us forces in the same direction. So if you have forces in the same direction, what you need to do is to add them together. So if we have forces in the same direction, all we need to do is what? Just to add them together. Since they're both going to the right side, with 1 Newton and 1.5 Newton, so all I need to do if I want the resultant force, so I say resultant force, F resultant, will be equal to F resultant, okay, it's laggy, just a minute, okay, F resultant is equals to 1 Newton, your 1 Newton, or 1.0 if you like, if you so wish, plus 1.5 Newton. So you're going to add them because they are moving in a straight line. So when forces are in a diagram and they are moving in the same line, if you want to add them, and if they are in the same direction, you just add them together. So this gives us 2.5 Newton. This gives us 2.5 Newton. Okay, because they are in the same direction. They are going in the same direction. They are both. These two forces are pushing this object. This is a mass, object with certain mass. Okay, this is an object with a certain mass. These two forces that are acting on it, 1.0 and 1 Newton, they are moving this object to the right, so to the direction of the right. So if you like, you can put the direction of the arrow of the resultant force on top of that to show it's a vector quantity. So meaning it will push this object will be pushed towards the right side. This is the direction of the arrow showing you the direction of the resultant force. Okay, that's for this. Now for the forces, now we have some force acting to the left and one force acting to the right for this second case. So forces in different direction. So if you have this type, you have to first of all add this and this together because they are in the same direction. So I'm going to add 1 plus 1.5. They are going in the same direction. That's why we are doing that. They are going in the same direction. So I will get my resultant on the left will be 2.5. That's my resultant on the left, right? Now it's presumed that this resultant force that is acting on the left will be pulling against 1.5. So meaning I will now have a new diagram like this. I can redraw it to show what it looks like now. So to the left, now I have one arrow. I have a resultant arrow of 2.5. To the left, I now have 2.5 Newton acting to the left. Why? Because I have added the forces that are all the total forces that the individual forces that are acting to the left. I've added them together because they are going in the same direction. So we got 2.5 Newton. Now to the right, we have only 1.5 Newton force going to the right, 1.5. So here we have 1.5. So we write 1.5. So how do you get the resultant force? Resultant force is simply like this. You say 2.5 plus minus. Why do we say minus? Normally we're supposed to say plus. Plus minus 1.5. Because it's opposite direction, that's why we say minus. That's why we introduce the minus. Because they are going in opposite direction. That's why we introduce this minus. Plus minus 1.5. So this will give us 2.5 minus 1.5. First, 0.5 minus 0.5, you get 2 minus 1, you get 1. So our resultant, this will be 1 Newton. Right? Will be 1 Newton. Right? Yeah. Will be 1 Newton. So our resultant force will be 1 Newton. So this is for adding forces in the opposite direction. This is for adding force. First, the ones in the same direction, you add them together, and then you subtract the one in the opposite direction away from it. Then you get your final resultant force. So we can always write resultant force here. F resultant. Let's not forget. Resultant force, because it is resultant force that we're looking for. Do you know what is this resultant force? I'm going to treat this topic maybe in the second or third class of physics. We're going to treat this topic. Okay? What is resultant force? Is the overall force that is remaining. One force is pulling to the right, one force is pulling to the left. What is the direction? Because it's going to the direction of the greater force. So this 1 Newton will be this way. We always put the arrow to show that is a vector, meaning it will be going to the left. Why is it going to the left? Because on the left you have 2.5, and on the right you have 1.5. So it must pull the object towards the direction of the greater force. It must push the object, just like tug of war. Tug of war, the thing will be the rope will be pulled, or the people will be pulled towards the direction of the bigger force. Okay, so this is how to do this one. This is very simple. This one is not an issue. The one that you normally find in the IGCSE paper is this type, the parallelogram one. So solve the unparalleled vector below and find the resultant vector and its direction. So you're going to find the resultant vector. Okay. Now here we use what you call the Pythagoras theory. Okay, see, you did it just now in mathematics. To find the resultant force, because here the first thing we do, can we change the color? Is it possible? You join from here to here to show the resultant, right? This is the resultant force. This is the resultant force, F arrow. F arrow. This is the resultant force, F arrow. Is that okay? This is the resultant force, F arrow. This F1, this F2. F1 is the vertical force, 2 Newton. F2 is the horizontal force, 4 Newton. And this is the resultant. To find resultant, you can see now this looks like what? Looks like a right angle triangle, right? Not looks like, it's now a right angle triangle. You can see here, this is a right angle triangle, angle 90. And remember, anytime we have that, we can use Pythagoras theory. We can use what? Pythagoras theory. And Pythagoras theory says the resultant, the hypotenuse side, F arrow square is equal to F1 square plus F2 square. Equals to the vertical force, the square of the vertical force, which is F1 square, plus F2 square, the horizontal force, plus the square of the horizontal force, F2 square. So this is Pythagoras theory. So we use Pythagoras theory to find the resultant force. This one, this resultant force. the magnitude of the resultant force. To find the direction, we're going to use the tan. This is to find the magnitude of the force. So magnitude, so I write magnitude. Magnitude means size, you know that, right? So to find magnitude, anything that is vector, you know you have to calculate the magnitude, and then you find the direction. So the magnitude, we use the Pythagoras theory formula, which I just wrote, magnitude. Then for direction, to know the direction, for direction, we use because the question says find the resultant vector. Resultant means the magnitude, that's the size. The resultant force or resultant vector. That's the magnitude. And then the direction. Direction is where on angular value of where the resultant force is going or is acting. Okay? Where the resultant force is acting. Okay? So here is solve the direction, you call it theta equal to tan inverse, or you say tan theta. You know, I just jumped to stage 2. Tan inverse of F vertical, the F vertical, which is F1. You can see F1 is the vertical one, is the vertical force. It's always the vertical force over horizontal force. Please don't make mistake of saying horizontal over vertical. It's always the vertical force over the horizontal force. The tan inverse. So this is the formula for direction. Once you know these two formulas, you can find the resultant force or resultant vector, and you can also find the direction of the resultant vector. Is that okay? So which means the resultant theta will be somewhere here. Which is, you say tan theta, in which you say tan theta is opposite over adjacent. Opposite over adjacent. Tan theta is opposite over adjacent. Okay? Now let's solve this one. So to find the resultant vector, let's change the color to blue. Okay, we can or purple. Okay. To find the resultant vector, I will be using F arrow for my resultant vector or resultant force. F arrow square is equal to F1 is what? 2 Newton. So I'll say 2 square plus F2 is what? 4 Newton plus 4 square. So you know, to make this one the subject, you have to take square root of both sides. So if I take square root of F arrow square to become only F arrow, right? I just want to skip that. I believe you know that already. So square root will cancel square. If I put square root here, it will cancel this square. So F arrow is equal to the square root of these values. Why do we take square root? Because you take square root of both sides to eliminate the square. So you have 2 square is what? 4 plus 4 square is 16. 4 square is 16. So 4 plus 16, we get 20. So our resultant force, F arrow. The arrow, if you notice, is a substrate. Substrate. It's small. It's not the same level with F. Okay, F arrow is equal to square root of 20. Square root of 20. 60 plus 4 is 20. So if you find the square root of 20, what do you get? You get 4 point something. It's not up to 5. 4 points. Okay, I will just approximate to 1 decimal place. It's supposed to be 4.47, but I'll just say 4.5, okay? So it's 4.5 Newton. You put the unit. What's the unit of force? Newton. So our resultant force is 4.5 Newton. So that's the magnitude of the resultant vector. This is the resultant vector, 4.5. Okay? So in IGCSE, this is the type of question you will see in the exam paper in physics. This is the type of question. Sometimes they may give you easy one like this. maybe in multiple choice, but a serious one in structure questions will be in this format. Okay, that's it. You've not finished it. Remember, they're asking us to find two things: resultant vector and its direction. So we need to find the second one, which is the direction. So I'm going to change the color so that it will not look exactly same with what we are doing. Okay, now let's use a bit of light purple. So the direction tan theta will be equal to the tan inverse of the vertical value, the tan inverse of the vertical value divided by the horizontal value. The vertical is 2. So 2 divided by 4. The horizontal is 4. The horizontal is 4. So 2 divided by 4, I think we will get 1 over 2, right? Which is 0.5. We get 1 over 2. And this is equal to 0.5. So we're going to look for tan inverse of 0.5. Tan inverse of 0.5. Press shift and then 0.5. Tan inverse of theta is the tan inverse of 0.5. You get 26.6. Okay, tan inverse of 0.5 So this gives us 26.6, or what you can also say approximately 26.6, or what you can approximately say 27. What you can approximately say 27. So meaning the direction of movement of the vector, the resultant direction of the vector is 27 degree. It's 27 degree. The unit is degree. You must put the unit. 27 degree. Is that okay? So that's for this type of vector using parallelogram method. Okay, this parallelogram method we just use. Or this is very normal in mathematics. This is called Pythagoras theorem, and this is called the TOA from trigonometry. We are using tan is opposite over adjacent. The TOA aspect of SOHCAHTOA. We are using this for the direction. We are using the TOA aspect of SOHCAHTOA for direction from trigonometry, and we are using Pythagoras theory for the resultant force. We are using Pythagoras theory for the resultant force. Okay? Do we understand? Okay. So now let's move to another question. Is it on your way to work in the morning, you drive 5 miles to a gas station. On your way to work in the morning, you drive 5 miles to a gas station. Okay, we can draw this diagram so it will make sense to us. So here's 5 Newton. Okay, let's assume the 5 mile is 5 Newton. You know we're going to use vector to solve it. So let's assume they are force. We just assume. When we finish, we will now put the resultant as whatever miles. You drive 5 miles to a gas station. That's vector A. To a gas station. So this is your house. You drive 5 miles. This is the gas station. Vector A. Okay. Before heading another 10 miles north. So before you headed north, another 10 miles. So this is 10 Newton. Okay. I'm just assuming that to be force, okay, because they say they are vector. 10 miles north to your office. Assuming you travel directly from work at the end of the day, what is the resultant vector of your drive home? So what would be your resultant vector? Assuming you drive directly from, this is your office, you drive directly from your office to your house, what would be the resultant vector? Right? What would be the resultant vector? Okay? What would be our resultant vector? And although they didn't ask us for the direction, but you must calculate the direction. Because since they ask you for what is the resultant vector, meaning both the magnitude, since it's a vector, you must determine both the magnitude and the direction. Is that okay? Now, this is easy, pretty easy, like what we did just now. Resultant vector is given as F resultant is equal to the F vertical, this one. You can simply just draw the, if you don't want to square, you don't want to make it faster, no need to square the resultant, this F resultant. Okay, let's use a different color to solve. Since the color for diagram and color for solving it, let's make them different, so it's more conspicuous to us. So this is this 5 square plus 10 square. This is 5 square, the horizontal square plus the vertical square plus 10 square. Okay, that's the all square root of everything. You get the resultant first. So you square this one. If you make mistake, you fail. Anytime you make silly mistake, you fail. You don't get you don't utilize the max. You don't get the max. So you must practice a lot to reduce mistake. What reduces mistake is practice. You practice a lot of question, mistakes reduces. When you don't do, you just act like you know it. You see in the exam day will be like your practice, and you make a lot of mistakes. So this time, this square you get 25. 5 square will get 25. 10 square will get 100. So we get 125 in total. We get 125. So we're going to find the square root of 125. So if we find square root of 1, we get 11.2, approximately 11.18, which is approximately 11.2. So we find the F resultant. We find the resultant to be the square root of 125. Okay, because you add 25 and 100, you get 125. So you can see this is pretty easy. You find you get 11.18, which you can approximate to 11.2. Okay, Newton. But if you now want to write the answers, remember it's in miles, so you can say 11.2 miles. That's what you covered home, straight from work. 11.2 miles. That's what the Yungu covers straight from office without going to gas station, straight from office to his house. That's what it covers. That's the distance it all covers, okay? Or the whatever it is. Now, because they say we should find the resultant vector, we must find the angle. Okay, we must find the angle. The angle, like I said, is always the vertical over the horizontal. It's always the vertical. So we say tan theta is the tan inverse, of the vertical distance over the horizontal distance. The tan inverse of the vertical distance is 10. The vertical distance is 10, and the horizontal distance is 5. The vertical distance is 10, and the horizontal distance is 5. So theta is the tan inverse of 2, because 10 divided by 5, you get 2. So tan inverse of 2. Tan inverse of 2, what do we get? So theta will give us 63.4. Okay, 63.4. That's the direction, angular direction. Okay, 63.4. That's the angular direction with which this Mr. Man walked through. That's the angular direction. If you measure it with how he started, and how he came back, the angle, all the angular travel he made that day, the angular movement is 63.4. That's the direction. Is that okay? So that's for this question. So with this, we've come to, it's just to tell you the IGCSE questions, how it will come, and what it is. Okay?